Hello guys, welcome back to John's Workshop, and in this video we're going to return to the workshop tips series. So this is workshop tips number 2, and hopefully, as you can see on the board behind me, we're going to cover a couple of things, and I'm using the industry terms for this, and I thought it'd be good to do that because obviously anybody like me who's spent years in industry will be familiar with these terms, but there'll be lots of people out there who do this as a hobby and may have never come across this, may have heard about it, don't really know what it is. So I thought I'd take the opportunity to explain some of that and also show it in practice, but largely around just showing some of the thought processes that go behind it. So the two principles we're going to talk about is DFM, which is Design for Manufacture, and very rarely referred to by its acronym, but MPP, which is Manufacturing Process Planning. So these are the two sort of precursors, if you like, in industry to actually starting to manufacture a product. So designing it to make it manufacturable, and then planning it so that it follows that manufacturable route through the manufacturing processes. And there's some select considerations on both of those, so I thought it'd be worth expanding on that. And we're going to do this around a real product that I want to design for myself, and also then go on to manufacture, and I'll probably do some of the manufacturing in a separate video as a project in its own right. So I'll bring you back in a bit closer at the board and we'll just start digging in a bit more detail. Right then guys, I've just tried my best to try and do this pictorially, and I'm just going to spend a minute or two on what happens in industry and what doesn't happen in industry. So typically in industry with DFM, you've got your designer, we'll say it's a designer in this case, singular, sat in his nice comfy air conditioned office with his cup of coffee and everything nicely all neatly laid around him, and he's busy working in isolation designing the finished product that needs to be made. And then there's kind of a layer in between, which is manufacturing process planning, which we'll come on to in a minute in the real world example. And then you've got your workshop space, and I've just drawn a couple of CNC machines there to reflect modern industry. So the design information flows through the manufacturing process planning layer into the manufacturing layer. Now typically the guy that works in here, and this is my observation from working in several large industries over my time and smaller industries as well, the guy that works in this space, other than his university college education, has rarely worked in this space, and similarly the guy that works in this space has rarely worked in this space. So when the guy's designing stuff, he really doesn't know what the limitations of this lathe are and this milling machine. He doesn't understand access constraints, length of tools required, access to difficult features, clamping techniques, work holding techniques, different tooling available, things like that. He doesn't really know that. He's got some ideas, and there'll be some, typically in large companies, some design rules that you follow, but largely he's unaware of the actual implications of what he's designing and how easy it's going to be to manufacture. And similarly, the guy that's working out here doesn't really understand what goes on in this space in terms of, if it's a critical product, say for aerospace, what the rules and regulations around weight and around stress and around thermal growth, and there's a whole load of stuff that this guy's proficient in that these guys really don't understand. So there's often quite a lot of mud thrown over this line, this guy doesn't know what he's doing, he couldn't make it rain, and similar. So you get quite a lot of this, and that's just big industry, and it'll be the same in any industry where you've got an in-house design and an in-house manufacture. Now even more so is when you've got an external design house and an in-house manufacturer. So if you're a subcontract manufacturer, even less so do the designers who design the product understand what capabilities you've got to manufacture it. So even more things crop up that are quite difficult to do. So that's the industrial application. We're not going to deal with that. We're talking about home shop here. In a home shop, there's only one person to blame, because in a home shop you are the designer, you are the manufacturer, you're the planner, you do the whole thing end to end. So in that respect it's much easier. And so that's what I want to come on to now. So I am going to do a bit about design of the actual unit that we're going to make in another video in a moment. So we're going to go through the kind of design constraints that this guy would normally be thinking about on a very simple application, and then we'll do a bit about process planning and the considerations around, once you've got your design, how do you then best plan that onto your manufacturing kit. So in terms of order of operations, tooling that you're going to use, work holding, and all of those linked together, and you're going to need to blend all of that together to get the best product out from a dimensional perspective to meet the finished, to meet the design requirements, and also to get that out in the most efficient time so that you're not spending 3 weeks making something that you should be spending 20 minutes making. So that's what the process planning piece is all about. And typically the guys that work in industry in that area have normally had a foot in both camps at some point, so they've got a bit of an understanding. So we'll wipe that pretty picture off the board now, and we'll start talking about the actual unit that I'm going to design and then go on to make in a separate episode as part of this video. Right then guys, I've done a bit of a list of things. I'm just going to quickly run through them. So what I'm going to make is a tap follower for the mill and probably for the lathe. So I don't have one today. I've often needed one, and it's a small project. That's something I've been meaning to make. So that's the product we're actually going to design and make and follow through this process. So I've called them constraints around the design, but largely in green that's the design brief. In red that's the DFM design for manufacture consideration. So just running through just the design brief. So it needs to fit multiple tap geometry. What I mean by that is some have centres in the back, some don't, some have a square, so it needs to suit both of those geometries, and it needs to suit taps that have different range of square sizes on the back end. It needs to be spring loaded, they all are, no point making one if it's not. It needs to be strong enough for the application that it's got to do, so it needs to be man enough for that. It needs to have a long enough stroke of the spring loaded element so that I get a decent amount of thread depth before it stops being useful, or before I need to move the tailstock, or before I need to move the spindle. It needs to be corrosion resistant, and that's part of the design brief just because of this workshop and the damp that I've got. It needs to be easy to use and easy to change. So obviously when I say change, I'm talking about the difference between a tap that's got a centre hole in the back and one that's got a square. So at some point there's going to need to be a changeover of end effectors. It needs to run concentric-ish. We don't know what that needs to be yet, we'll get into that when we get into the design. And it needs to have adequate spring pressure so that when you do put it under spring load, it's strong enough to hold the back of the tap in position, so it's not all wishy-washy. So it needs to have a strong enough spring to do that. Now if we look at the DFM consideration, so if I looked at just those on their own, I would probably design a tap follower. But if I now look at my manufacturing considerations, it needs to be suitable for my machines to make. And what I mean by that is, there's no point me designing something that when I come to manufacture it, I need to, on the lathe, hold it in a collet holder, because that's the only way I can grip it because of the design for the second operation, if you will, because I don't have a collet holder on the lathe. So I've got to design it around the work holding that I've got and on both machines to manufacture it. It needs to be within the scope of my tooling. So again, there's no point me creating a design where I've got some fancy beveled feature that needs to be at the bottom of a hole and you need specialist tooling to put that in, specialist angled tooling that I then need to go and buy because I don't have that already. So I need to consider what tooling I've got against the geometry that we're going to come up with to make sure I've already got it, because for something as simple as a tap follower, I'm not going to go out and spend lots of money on expensive tooling. It's not worth it. It needs to fit into both my lathe and mill chucks. Now you could say that's not a design for manufacture, that's more of a design brief, and it really is, but I'm calling it the DFM because I want to use this across both my machines. So the constraints on the OD of the thing is it needs to fit in a 13mm chuck on both machines. So that's I already know my size of my shank, if you like. Needs to take proportionate effort to make. So again, I could come up with a fantastic design that takes me 3 days to make, where I can buy one of these things for probably 25-30 quid. So again, it needs to be proportionate with what it actually is. It needs to utilise available material. So again, there's no point me designing something that I then go, oh, I now need to buy a minimum quantity of 1/2 metre length of bar stock in some fancy material that's going to cost me 60-70 quid to get it delivered to make a tap follower. So I've got to look at the bar stock that I've got and make sure that it fits within the design envelope, fits within that bar stock. And lastly, and this isn't designed for manufacture, that's why it's in blue, but it's another consideration, it needs to make good YouTube material, and that's to keep all of you guys happy. So I'm always thinking about, when I'm doing a project, is this going to look good, is it going to make a decent project, is it something that somebody else could follow? And again, going back to the needs to fit my machines, needs to fit my tooling, you could just go, well, I'm just going to go and look on YouTube and look at someone else who's made one of these and look for the best I can find, and I'm just going to make that one. And that's not a bad idea, it's not a bad thing to do, but without thinking about these DFM considerations, if you just do that, you could get halfway through it and then realise that the guy that you're watching has actually got much different kit to you, which means he can make it fairly easily, but you don't have that same kit, so you can't, and then all of a sudden it becomes a nightmare job, because you then can't make it to the original design that you wanted, and you start struggling. So it always pays, even if you're copying somebody else's stuff, to think about these DFM considerations to make sure that you've gone through the design and it fits your material, fits your tooling, fits your machinery, it's economical to make and manufacture, it fits with the material that you've already got if it's a cheapish product to make. So they're the kind of DFM considerations that you need to think of on this particular project, and these will vary depending what the project is and the complexity of it, but for this particular project these are the real DFM considerations. So we'll come back now and look at the manufacturing process planning element of it, and then we'll get into the design. Alright then guys, we're going to move on to the design. I know I said the process planning, but I was just testing to see if you're all awake. Obviously you can't do that until you've got a design, so we're doing the design first. So I've roughly sketched, and this is just, I'm going to walk through how I would go about this. So this is just a rough design of something like what I'm going to think I'm going to end up with. So spring loaded, so the red part's the spring. I've got a threaded plug in this end that I can remove, which means I can remove the spring, which means I can remove the pin, and it's probably quite hard to see on the camera, but what I've drawn here is a counter bore all the way down here deep, and I've drawn on the pin, so the pin's double-ended and it's got a diameter portion in there that seats into this counter bore diameter. And the reason for that is then you've got two bearing locations, for want of a better word, one on the OD of this and one on the OD of this going through the front, which means it's quite stable from tipping this way. I've drawn roughly a bung on the end of the threaded plug at this end to locate in the inside diameter of the spring, and obviously this shoulder here that I've just spoken about serves two purposes. One is the location, and two, it serves as a face for the spring to put up to. And what I've tried to draw there as well, just very roughly, is because this is a double-ended pin with two uses, obviously the back half of the pin only needs to take up about 50% of the length of the spring, whatever the length of the spring is, so that then when you compress the whole thing, there's room for this to move back up before it bottoms out on the plug at the back. So, and all of those dimensions are yet to be figured out. So I thought what I'd do first is understand, I know I need this double-ended for two different styles of tap, so we're going to go to the bench now and I'm going to understand what the design elements of this pin need to be for a start, and then we'll start breaking this out into a full design. So I'll bring you in at the bench in a moment and we'll talk about this need for the double-ended pin. So I've got my taps out. These are just my metric taps, and just for demonstration purposes, So if I just pick one at random that's going to show what I'm talking about, so we've got here an M12, so this is an M12 tap, and if you look in the end of it, you can see we've got a centre dimple in the end of there, and let's assume this is the pin with the pointy end. That will locate neatly into that centre pip, no problem at all, so that'll work okay. If I take another M12 tap that's right next to it in the same box, and you look in the end of that one, there's no centre pip at all, so you know, trying to hold this up against the end of that is going to do no good whatsoever. So I need, and what I'm going to design is a cup of some sort to sit over the end of this tap. And then if I look across the full range of my taps, you know, if I go down to my sort of smallish ones, so these are M3.5, I think these are. Obviously no centre hole in there, they're sort of, you know, rounded off to a point, right the way up to probably the M12 is the biggest one that I've just shown you, where we don't have a centre pip in. So the range the cup needs to cover is this being the biggest square, and probably actually I've got a smaller set of taps here going right down to 1mm being the smallest square. So I need a cone shaped cup that's going to cope with the difference in square size between these taps and this tap. So that's my sort of design constraints. If I go to the bigger taps, so M16, M20, M24, they're all right the way up to M24, they've all got the centre pip in the back, so they will all be fine with the pointy end of the pin. So I now know what my constraints are for the second end of the cup. So the problem that gives me, if I go to my biggest square, which is this one on the M12 tap, if I look at the size of the cup I need to cover that end of that tap, that's probably far bigger than the internal diameter that I've got to play with inside the unit itself, because don't forget my other constraint is I want it to fit in my milling machine chuck and my lathe chuck, which means the OD of the tap follower can only be 13mm. Well, this is probably about 8-9mm across there, and my cup will need to be slightly bigger, so obviously that leaves no room for the spring in diameter wise. So I've got some design constraints to work around this style of tap. So we'll go back to the board now with all of that information and start to draw the design up. Okay, so what I'm going to do now is just start with stuff that I know. So I know that I'm going to need a body, and I know that that's going to have a tapped hole in this end. Size yet to be decided. It's going to have a counterbore that runs through here. I know I'm not drawing this dotted, but for now it will do for what I want. I know it's going to have a hole through here. So I've got my tapped hole, my counterbore, my hole through the end for the pin, and the only thing that I know about this at the minute is my constraint here is this diameter. I'm not drawing that very well because I'm all cack-handed. $13mm. So I know my constraint there on diameter. I also know that I need a pin that's double-ended, and I don't know what this is going to really look like yet, but we're just going to draw something roughly like what I want. I know I'm going to have a point on one end, as we've just discussed. I've got my shoulder, and I'm just going to leave that end for a minute because I don't know what I'm going to design on there yet, so that's still to be designed for the cup end for the taps. And I also know that I'm going to need an end bung to fit in the back of here, and we'll imagine this is a knurled, I don't know, a knurled nut it's got its thread here, and it's got some kind of spigot on the end for locating in the spring. So here's my thread. So those are my three components. I know this end's going to be pointed. I don't know what we're doing here yet. So I'm thinking this through, and I'm thinking this on the hoof. I've not done any pre-thinking with this. Bearing in mind this is 13mm, my maximum thread size I can really put in here is probably a 10, an M10, maybe an M11 if I've got one, which I don't think I have. So that would have to be M10. So I now know that my bore size here, this bore size for the counter bore is going to be probably 10mm. It might even end up smaller than that yet. It might be 9.5, but we'll go for 10 for a start, and we know this is going to be M10 thread. So I'm already starting, even though I don't know everything about this yet, I'm already starting to gather my thoughts. So if I now imagine my spring sat in there, as I showed it earlier, so I've got my spring that's going to sit in here, and I'm just going to draw roughly a spring of some description sat in there. The biggest diameter that spring can be is clearance on whatever size we make this. So if we're saying this potentially is going to go down to 9.5, if I now draw my spring as a separate unit, and I'm not going to draw it properly, but you get the idea. So this is my spring, and I'm just going to curly whirly it for speed. So I now know that my spring maximum diameter is probably going to be about 9mm, no bigger than that. If we assume that that spring's got probably, I don't know, let's assume it's got a 1mm wire section there or thereabouts. So if I take a mil off one side and a mil off the other, that means my bore size, which is my effectively my maximum pin diameter. So if I now draw that in, I'm probably, if I'm saying 9mm, 7mm ish potentially, and all of these dimensions are yet to be verified. I'm still waiting for springs to turn up, so I don't really know. So we'll say 7 for now on that spring size. So if I now go back to what I just spoke about, the cup end, the biggest end that I needed was, I think I said about 10mm. I do need to measure it, but it's certainly going to be bigger than 7, which means I can't really put a cup on this end because it's not going to work, it's not going to do the job. So I'm thinking about this now and thinking, well, how can I do that differently then? So what we'll probably do, and I'm doing this on the hoof, I've given this no pre-thought, we drill and tap a hole in here. Oh, that's not done very well, is it? But you get the idea. And that's, if we're saying this is 7, that's probably going to be an M5 or an M4, yet to be decided. And then I'm thinking now what I could do is create a 3, 4, 5th component in the assembly, which looks something like this. And I'm working aloud here. Well, I've got that, and I've got a, I don't know, this, which is a M5/M4 thread, and inside here I cone this out. So I've now got my cone, and then I'm just thinking what I could do actually is drill a hole in here and tap it in the back of here, M5/M4, whatever we end up with, which means when I'm not using this cone end, rather than it being a loose piece that's going to get lost, I can actually screw it in to the end cap. So when I'm using the pointy end, the cone can be screwed into the end cap there. When I want to use the cone end, I take the assembly apart, pull the spring out, unscrew the cone end, screw it into the end of this shaft, once I've fed this shaft through the body, and then I've got the option of fitting all my taps, and I can make this cone here any size I want. So what I'll probably do is go through my imperial taps as well and just check that I've not got any bigger ones that need the cone, and I'll make this to suit. So I'm just going to put here to suit biggest square. So that's some rough dimensions as part of the design. One thing we've not spoken about here is any of the lengths this way. So don't know how long that needs to be, no idea how long this needs to be yet, or this. All we do know is that will probably be equal to that, and I can't calculate these until my springs turn up, because I need to measure the length of my spring. So once I know the length of my spring, once I know what that dimension is, I then know that this dimension here between there and there needs to be at least half that dimension, so that I've got room for this thing to work inside. Once I've got that side calculated, I can then work out what that shoulder width needs to be and what the overall length of this part is. I've pretty much almost got everything I need for that component then, and as we move on to this, I can then start joining the dots. Once I know what the length from the shoulder to the end is, I know what the spring length is, I can then calculate this overall length, and you can see how I'm building the design as I'm going. So this is all about understanding the moving components, how it's all going to fit together, and how you can start littering dimensions on it. And as I've said, all of these at the minute have really got question marks by them, apart from that one. That's the only thing that I know at the minute, potentially. Everything else has got question marks by it, and I'm not going to know that until my springs turn up and I can take the data from that spring, feed that back into this design, and then start really firming the numbers up on all these other dimensions. But they're going to be there or thereabouts what I've got on the board. So that's how I would go about a design of something like this. And you know, you can clearly see I've not copied any of this from anybody. There'll be things that look like this, but I don't think I've ever seen one with a separate cup, and certainly not one that screws into the back of the nut. So I'm doing this live just to show you how I would go about designing something like this to get the best out of it. Once I do get the dimensions on, I'll then start refining the design slightly, and just making sure it's fit for purpose and it's going to do what it needs to do. So I'll cut this here, I'll wait till my springs turn up, and then I'll bring you back once I've started littering some dimensions on this and walk you through what we've got. So what have we got on the bench? So this is my box of springs that I ordered. I've got no springs in the shop at all, so this is the only thing that I've actually purchased for this build, and obviously these will stand me in good stead for future projects. And you cannot believe how many redesigns we've done around 2 or 3 different spring types, this being one, and I've been trying to gauge, you know, spring pressure that I need. This was nearly the chosen weapon, but the compression of that is really too strong, and I just don't think that was going to work. So we finished up with this one. So once I knew that overall length, I could then start building those dimensions back into the design. So this is the spring that we're going to use. It's got a reasonable, you know, I can pretty much compress that nearly all the way in by hand, but it's taking a reasonable amount of pressure, feels about right. And then from a materials perspective, we've got some 304 stainless steel, 16mm diameter, so that's going to make the main body. We've got some 17 4pH that's donkey's years old, which is a ferritic stainless, that's why there is some rust on it, and that's going to make the main pin, the double-ended pin. And we've got this bit of probably mild steel or something here, and that will make the other 2 parts, so the threaded end cap that goes in the end of here, and also the cone element that's going to hold the back end of the taps. So I've got all the materials I need. I've been using the good old Zeus book, checking all my different threads and tapping drill sizes as I've been trying to work out which spring sizes to use. So all of that's gone through that whole design process. So we've got materials, tooling, and a plan to take that design into the manufacture. So there we go, guys, and I realise I've probably not done DFM justice there, if I'm honest. It's a very complex topic, and trying to cover that in sort of 20 minutes, half an hour, as well as the design of a component as an example, is quite a difficult thing to do. You know, DFM is a massively complex topic. There's lots of things I've not mentioned that I keep thinking of that I should include, but I could go on for hours on this topic. So it could be something we drill down into more depth on in the future. But one thing that I did want to say, the earlier diagram that I drew up there where I'd got the design on one side and the manufacturing on the second side, in industry, certainly in large industry, well, and small and medium industries as well, what typically happens, and I know you remember I said the designers probably never worked in the manufacturing space and the manufacturing guys have never worked in the design space. What you typically get is DFM sessions, or DFX sessions they're sometimes called, or design make sessions they're sometimes called, where the two teams will come together and discuss the design, discuss the manufacturing methods, and start to share ideas. That typically is how it's done in industry, but more recently, in more recent times, what you tend to find is that doesn't happen that often. So you've got a designer working in absolute isolation, making stuff, and I've been several times in my career on the receiving end of that, where we've been given a drawing to make something, and it's absolutely physically impossible to get tooling anywhere near the features that have been designed into the product, and that's just through lack of knowledge of the guys designing it. You know, they know they want a hole in somewhere and a pipe needs to go into it, but they've got no idea how you're actually going to get that hole in there, but it's the right place in the design space for the hole to be. So that's DFM in a nutshell, at a very, very high level and a sort of a worked example. I hope you found that interesting, and if any of you are still left, probably the one or two of you still left listening, I hope you found it interesting, and we'll catch you all very soon on another video when probably we'll be making the tap follower, but certainly if it's not, then I'll be making that tap follower in the next couple of episodes or so. So as I said, hope you've enjoyed it. Thanks for subscribing to everybody, and we'll catch you all soon.